Hello, and welcome to your OSHA Annual Awareness Training course for Process Safety Management, or PSM, specifically covering the topics of ammonia and combustible dust here at our Unilever Independence facility. I'm your host, Gabe Kappen, SHE Supervisor. So what is PSM, or Process Safety Management, and how did it arise? Well, there was a tragic incident that occurred in 1984 in Bhopal, India, in which a Union Carbide pesticide plant had a catastrophic release of methyl isocyanate. This release was so dangerous in nature that it immediately killed 2,500 people, and by the time the incident was over, killed over 20,000 individuals. There were also many other non-fatal injuries off-site. As you can see in the picture of the plant there, it was located in a densely populated area. This incident was so severe that it actually led to the OSHA regulations promulgated in 1992, which led to the PSM standard. Since then there have been many other, less infamous examples of industrial accidents and chemical releases. Fortunately, nothing to the level of the Bhopal disaster. So process safety management is essentially a process which we use to ensure that systems for handling and using highly hazardous chemicals are as safe as possible, not only for our employees, but also for the communities around us and the environment. The PSM standard is outlined in OSHA Rule 29 CFR 1910.119. And the whole purpose of this is to prevent and minimize the consequences of catastrophic releases of toxic, reactive, flammable, or explosive chemicals. Our PSM program has 20 elements that cover various areas to help mitigate any risks from handling these highly hazardous chemicals or combustible dust. We'll go over them here in the next slide. Please take a moment to look over the different elements of an effective PSM system. You don't need to memorize all of them, but we do need to know that these different elements are grouped into various areas that help us have an effective process safety management system that keeps everyone safe. Namely, the main categories are understanding the hazards and risks with the materials we're using, how we can manage those risks, how we can learn from experience from prior incidents or incidents at other facilities. And then we also have to have a leadership commitment to process safety. Our leadership needs to be present and also provide the resources necessary to have an effective PSM program. So why does Unilever Independence even have a PSM program? Well, first, it's because we have an ammonia-based refrigeration system on site that contains 3,600 pounds of anhydrous ammonia. While OSHA sets the standard at 10,000 pounds as a threshold to have a PSM program, Unilever takes an extra step and mandates that we follow the OSHA PSM standard even though we have a smaller system. This is good in and of itself because it makes us follow these guidelines and the framework that keeps everyone safe as well as our community. We also have a reasonable combustible dust risk here at the facility with many of the dry ingredients that we use in savory process as well as in our tea production plant. We're going to start here and cover the hazards and precautions related to ammonia use at our facility. So as I said, our refrigeration system on site that's used to chill the pack hall uses ammonia as its primary refrigerant. Well, let's start here. And what exactly is ammonia? Well, anhydrous ammonia is 99% or 99.9% pure ammonia. Anhydrous meaning it does not contain water. It's a colorless gas or liquid if it's compressed, has a strong odor, it's extremely cold as a liquid, which makes it a good refrigerant, and it can be hazardous to people if exposed to large quantities, which we'll go over on the next slide. If you are exposed to ammonia, it is a high health hazard. Symptoms of ammonia exposure can range from coughing, watery eyes, to severe burns on your skin, eyes, throat, or even lungs. Severe burns may be serious enough to cause permanent blindness, lung disease, or death. This slide does a good job of going over the details of exactly how different concentrations of ammonia have an effect on the human body. At just 5 ppm, so that just means 5 parts per million in the air, you can actually smell ammonia. At 50 parts per million, it can harm you at a long-term exposure rate. That means if you were to work in a 50 ppm environment for, 8, 12 hours a day for years, it can cause long-term damage. At 300 ppm, it's an immediate danger to your life and health. That's what we were talking on the previous slide about some of that, coughing, lung damage, organ damage, skin burning sensation at that level. And at 5,000 ppm, it can kill you in a matter of minutes. So the basic rule is if you can smell ammonia, you need to be concerned. Move out of the ammonia cloud as soon as possible and immediately notify others. Now, the good thing with how our ammonia refrigeration system is set up here at Independence, all of our ammonia, all 3,600 pounds, is actually housed off-site in a separate building located in the ammonia engine room at the east side of the plant. Ammonia never enters our facility. Note that the engine room is a restricted area, and please do not enter unless authorized. This satellite view of our plant shows you exactly where the ammonia engine room is located. Actually, where I'm going to be drawing this line, there actually is about a 10-foot separation, 10, 20 feet between the building, the ammonia engine room, and the actual pack hall. So as I said before, no ammonia would enter our main production building. Now the shelter in place location here is located here for a number of reasons. A lot of people would think, well, if we were to have a catastrophic release of ammonia to the atmosphere and to the environment, we'd want to have all of the workers go outside to get fresh air. That's simply not the case. When ammonia systems are put in, they conduct air dispersion modeling, and we've determined that the safest place to be in the event of a catastrophic release of ammonia is actually at that shelter-in-place location located near T process. You are much less likely to be exposed to ammonia at that location. If you were to meet possibly at our normal fire drill rendezvous point over here, and let's say the wind changes direction, that could potentially put the whole plant at risk of being in that ammonia cloud. So the safest place to be is in that shelter in place location. And as you all know, we shelter in place when we hear an intermittent alarm. As I said before, all of our ammonia is housed in the ammonia engine plant located separate from our main production building. So the likelihood of smelling ammonia would be very rare, which is all the reason why we need to take this very seriously. So if you're in the plant and you do smell ammonia, you need to make sure that you notify your supervisor or someone from management right away, preferably someone from the sheet department or building maintenance or even the factory director. This way we can investigate the leak. If it's something minor, we may be able to respond to it and correct it. If it's something major, we may need to get a hazmat team in. It's also important that we report any leaks because it's also a regulatory requirement and it's a Unilever requirement. Depending on the nature of the incident, we may have to report it to the EPA or to other regulatory bodies. As an extra safety precaution, our ammonia engine plant is actually equipped with automated ammonia sensors that go off at certain levels. At just 25 parts per million, the alarm will notify building security, and trained and authorized building maintenance technicians will be dispatched to investigate the leak. At 300 ppm, the intermittent building alarm will sound and the whole system will enter shutdown. All employees will need to follow emergency response plan and then go to that shelter-in-place location that we talked about earlier. At the higher concentration, if we need assistance to troubleshoot the leak or to fix the system, we'll likely have to call local fire department or a hazmat response team that has the right PPE to come in and respond to that leak. Pictured here are the different routes you may take depending on where you work in the plant to get to our shelter-in-place location located near T process. We shelter in place at the Independence facility for two reasons. One being an ammonia leak and the system hit 300 ppm and that intermittent building alarm went off, or if we have severe weather in the area and we'll sound the intermittent building alarm for that reason. The shelter in place location is located just south of the T control room. Now we're going to take a look at the hazards presented by combustible dust here at Unilever Independence and how PSM helps control those hazards. First off, we need to know what things in our plant actually are considered combustible dust under the right conditions. It turns out a lot of different things. Basically, most of our ingredients used both in savory and tea process can be combustible dust in the right conditions. That includes our tea leaf and powder, sugar, maltodextrin, cornstarch, corn syrup solids, whey, garlic powder, and onion powder, among other dry ingredients. These are located throughout the plant in tea blending and at the dryer, in all of our savory process areas and packaging, as well as in the warehouse. So what turns regular dust into combustible dust? Well, first you have to have a significant accumulation of dust over time on flat surfaces. Then some event occurs that disturbs the settled dust and puts it into a cloud. And then you have to have some kind of ignition source to ignite that cloud of dust. Basically, you also need all the 5 elements in the dust, fire, and explosion pentagon pictured here to have a combustible dust explosion. The first 3 elements are needed just to generate a fire would be combustible dust as the fuel, an ignition source, which would be the heat, and then the oxygen in our air, which would be the oxidizer. An additional 2 elements must be present for a combustible dust explosion. Number 4, dispersion of dust particles in sufficient quantity and concentration. And number 5, confinement of the dust cloud. So if you had a fire in an event that kicked up dust, but it was outside, you wouldn't likely have an explosion because it's not confined. When you have the dust kicked up in the air and an ignition source hits it in a confined area, such as a factory, that's where it really becomes a combustible dust explosion risk. And then you also have an issue where you may have that initial explosion might kick up more dust in the air in that confined space, and that triggers a secondary explosion that can actually be much more hazardous and much more fatal than that first explosion. The images below show just how powerful a combustible dust explosion can be in real life. At the Bartlett Grain Company in Atchison, Kansas back in 2011, 6 workers were killed in a combustible dust explosion that involved grain. The explosion was so powerful, it was actually felt by individuals up to 3 miles away from the grain elevator. To help mitigate the risk of a combustible dust explosion, we have a number of dust control measures employed here at Unilever Independence. First and foremost, we have dust collectors. Our air is filtered and the dust in the air is trapped in our filtration system, and we swap out the filters periodically. We also have a housekeeping program where we clean certain areas of the plant on a defined frequency. Typically, our largest cleanouts being during our summer and winter shutdowns. We also have engineering designs to help minimize dust accumulation, such as in the picture on the left there. Some of our racking in the warehouse, the steel support bars are actually at a 45-degree angle, so dust does not accumulate on those surfaces, but rather collects on the ground where it can be cleaned up more easily. In addition to controlling the amount of dust found in the plant, we have a number of protective measures in place as well. These include proper electrical installations and insulation to make sure that electric sources don't present as an ignition source for combustible dust. We also use proper EE-rated forklifts in areas that have a high density of dust. We have static protection devices, explosion relief venting, and isolation devices in the ductwork that would transfer any energy from an explosion out of the plant rather into areas where people are. And then we also have our emergency action plan. So what can you do to help combat the risk of a combustible dust explosion here at Unilever Independence? Well, first and foremost, please keep up with your housekeeping. If we can work to try to eliminate the source of dust, then the risk of having a combustible dust explosion is virtually zero. Secondly, proper maintenance of equipment also helps. If you see a filter cartridge or something that's clogged with material and dust, swap it out sooner than later. And then also very important, if you see any unsafe conditions, such as the ones pictured here, where there's a massive accumulation or buildup of dust, please report it to your supervisor or the SHE team or building maintenance. That way we can work to schedule time to get that cleaned up and eliminate the risk. I want to thank you for taking the time to go through your annual refresher training for process safety management covering the topics of ammonia and combustible dust. Please make sure you answer all the questions in Weaver Apps and click submit and write in your name. Thank you.